All right, we're going to do another density calculation here. This time we're given a density and we're asked to calculate the radius of a gold atom in angstroms. All right, so let's go to this problem, and the density of gold is 19.3 grams per cubic centimeter. Molecular weight is 197. Now, in this problem, we know it calculates, or it crystallizes in a face-centered cubic arrangement. So face-centered is using this formula right here. All right, it's going to be with the one with the 4 atoms. All right, that's face-centered. All right. So our density, so 19.3 grams per cubic centimeter, is going to be equal to, we're going to have four atoms times, we know the molecular weight of gold is 197 grams per mole, and then we know that Avogadro's number is 6.022 times 10 to the 23rd atoms per mole. And that's all going to be divided by, I'm going to regroup this denominator. It's going to be 2 to the 3/2 times R, and that's going to be quantity cubed. All right? So 2 to the 3/2 times R quantity cubed. However, what I'm going to do is, I'm going to do a little trick. I'm going to go ahead and initially distribute the cubed here. When you do that, this becomes 2 to the 9/2 and then times R cubed. All right? And so I'm ultimately going to be solving for R cubed. So what I'm going to do is I'm going to go ahead and multiply everything. So it's going to be 19.3. I'm going to have to get the 4 over here, divide by 4. So it's going to be divided by 4. It's also going to be divided by 197. So divided by 197. And then I'm going to have to multiply by Avogadro's number, so times 6.022 times 10 to the 23rd. Okay? And then I'm going to have to multiply by 2 to the 9/2, so times 2 to the 9/2. Again, parentheses are very important. And then that gets me this number, and it is about 3.337 times 10 to the 23rd. And that equals 1 over R cubed. So if I want to find R cubed, I need to take the reciprocal. So R cubed is going to be, let's take the reciprocal of that. So it's 1 divided by second answer on your calculator. And I'm getting this is almost 3, but let's just say 2.996 times 10 to the minus 24th. And that's going to be, remember, these are going to be units now. These are going to be centimeters cubed. The reason this is going to be centimeters cubed is because the density is given per cubic centimeter. So now if I want to find the length in centimeters, I need to take the cube root. So I'm going to, on my calculator, go to math, and then there's a cube root function. So cube root, second answer, and then I get that the radius is approximately 1.44 times 10 to the minus 8 centimeters. And if we remember that there are 10 to the 8 centimeters in an angstrom, this is also equal to 1.44 angstroms, and that's going to be the radius of the atom. Okay? So hopefully that makes sense on how to do this kind of problem. So this is where we're solving for radius, but instead of giving us a length of the unit cell, they give us the density. All right? So that answered this question. Hopefully that made sense. We're going to do another problem in the next video. All right, join us.